get it ready for the May 19th event. Some things I haven't tried before and some things I have. I'm also going to show you how mission control is modular in a small way. And that'll be it. Let's get started. All right, this is mission control, my 1 pound antweight. It is not a plastic antweight, even though it is made out of a lot of plastic. It is made out of nylon, and the rear wedge is titanium, 1mm titanium. The lifter plate is 1mm titanium, and the claws are also 1mm titanium. We will be doing 2 modifications to it today. One will be to this bar right here, and then I will also be adding a spring to retract this bar in some cases. Mission Control is a very tanky robot. It's not particularly fast, it's not particularly agile, but it is particularly tough. It can take anything that any robot can dish out. Anything that's going to break Mission Control is going to break any robot in the field. I'm pretty confident about that, with one major exception, and that's this whole mechanism up here. It is inherently weak. It's a small servo with a linkage that makes the claw go up and down. Now, the linkage provides some isolation for the servo, so when this takes hits, if it's getting hit left or right, all of that energy gets transferred down into here. No harm, no foul. It really does fine. If it gets hit with an uppercut, that can cause this to be damaged, and we're going to take some action to deal with that, and we're going to be adding a feature to help help Mission Control remain competitive if this servo is broken. So the first thing we're going to do is replace this linkage part, this wire, with a new one. And all we'll be doing today is adding a little kink in the wire that will allow it to flex when it gets hit. Basically, I'm going to turn this into a spring. Now, the first thing I want to do is I want to take this and I want to shape it like you see here on the robot. So it is a little U that leads out to from there. So how do I shape it? Well, I take this wire, simply cut it with the clippers to the right size. I just bought this at the hardware store. Now to bend it, just put it in the pliers, leaving as much as you want to bend, and then just with my thumb, I just push it down until it's at a 90-degree angle. And oh, it's not quite at a 90-degree angle. Just bend it a little bit more, and there you go. The next bend, just as simple, but I am limited by the width of the pliers, so the thicker the pliers, the less tight the bend can be. And also you want to make sure to keep the bend on a single plane, because if it rotates a little cockeyed like that, it's extremely difficult to fix. So anyway, just bend it with my thumb, holding it tight in the pliers, and then we end up with a relatively nice angle. And then I can take the pliers and I can finish it off, making it a little bit tighter. Do it that way. There we go. Good enough. So now we've got another one that looks pretty similar to what we have in there now. It's not quite as slick, so we can fiddle with it later. But now the next thing we need to do is we need to add that spring action, and all it's going to be is a kink in the line. So we're going to start with it going up, and then back down again, like so. Let's see here. Make it a little tighter than that. There we go. Back up again. All trying to keep it all in the same plane. Straight as an arrow. And now that I've got that, I want it to come off this line still straight as before. So I get that marked right there. And boom. is what we've got. And we've got a little bit of flex in it now that wasn't there before. Okay. Hopefully it doesn't catch on any of this stuff. It should be all right. Now that we've got that, we need to make it bend it at the same length as this one, or close enough. We can use the trim on the radio to adjust it a little bit. There we go. And this one's just going to go all the way around like that. Not very pretty, but it'll work. There we go. Trim off the extra bit with the clippers. And you have a piece that's roughly the same as this original one, but not. Take it off. Off. Put the new one in. That. Use the pliers to tighten it up. Ooh, sparks. There we go. Now, put the screw back in. And there we have. See, it's got a little bit of flex to it, and that should help prevent energy from being transmitted from here to here. Now the next modification is a little bit funnier. When this breaks, and this goes flat, I usually lose. And part of the reason is that this is flopping around and it just gets in the way. I can't even use my lifter as a lifter with this in the way. And also, when I get flipped upside down, when this is in the down position, there's not enough energy, not enough angle to flip my robot back over again. So the solution is going to be, I'm going to add a spring that will hold this in the up position as the default if this goes slack. Now I've already tested this, so I know it'll work in theory. I've already put the spring on, but I will show you how it all works. I have an extra hole right there, already pre-printed into the side of the thing. I wanted to have some adjustability for this, and it goes all the way through the arm. So I'm going to hold my spring in to that, and then I'm going to use this, which is just a bolt that holds this top bracket in place. All right, so I've got the spring. It's going to go right in there. Okay, there we go. And that is the spring in place. Now what that's going to do doesn't look like much, and it certainly could break, but the worst it's going to do is not make anything worse. But check this out. If this thing goes slack, boom, that goes in the up position. My lifter is still available. Yeah. And I don't think it's going to be strong enough. Might even be strong enough to flip me back over. We'll have to test that. That is not my primary goal. My primary goal is to continue to have a lifter if this goes slack. All right. And that is how you upgrade your robot. Well, it's how I upgrade this robot. Now lastly, I want to show you Mission Control has two scoops, pointy one and a square one. Now the square one is what I've used for years and years, and it's an excellent way to get under many, many robots. It provides maximum leverage, a lot of surface area to catch the other machine and flip them over. It isn't ideal for wedge type bots. There are the bot kits, Candy Wasp robots. They're fast, they have a low hinged wedge, and they really have caused me nothing but trouble. And I need to get under a hinged wedge like those Candy Wasps use. And my solution is to go from this flat plate with a lot of area for them to get under and replace it with a pointy one. And that will provide a single point, so if they catch me from anywhere else, they'll get under me. But if I hit them with the point first, I believe that will get under a hinged wedge, and I will win that battle and possibly flip them over, possibly grab them. At least that's the idea. We'll see. In order to change these plates, I'll like to show you. And this is something that I would certainly do within the context of an event. So goes right in. I use wood screws that go directly into the plastic. The holes are printed into the thing. There's four, one on each side and two underneath. And they're slightly larger than the wood screws I use for most of the robots, because this is going to be taking direct shots. This is going to be likely to break if anything is. All right. In fact, let me show you what the old plate looks like. This is a brand new one. Everything about it is new. This is what the old plate looks like, so you can compare. And it's been flattened and hammered. I've heated it. I've ground it flat. I've done everything possible to keep this thing useful, and it has been. I mean, it's no longer very straight, but it is straight enough to function. But in this case, new is better. So we're going to put on the triangle plate. It just slides right in place, and then the screws go back in place. Same as this one. These are the same parts. The only difference is the shape of this 1mm titanium plate. There we go. So while there's more work to do, including the plastic antweight hoopty bot, Mission Control is sorted and ready to fight. That's interesting. This spring is affecting this spring, so they're working kind of, I don't know if against each other or with each other. It's hard to tell. As long as it opens and closes, it'll be fine. We'll see. Well, we'll see. We'll test it, and if it ends up causing problems, we can go back to a solid shaft here, like we had already with that one, or we can remove this spring if it's causing problems. But for now, I think it'll be all right. Mission Control, the #1 hazardous toy.